Okay, let's look at homework number 8, problem number 28. Right. So we want to find the absolute maximum and the absolute minimum of this function over a closed interval from 6 to 22. Right. So let's do that. Alright, so first thing we need to do is we want to find the critical numbers, so critical values. So we have to take the derivative. So f prime of x is equal to, right? So this is a product rule. So here, this is our first guy, and this is our second guy, right? So derivative of the first is 1 times the second. So quantity x minus 20 raise it to the third power plus, right, first guy x minus 4, right, multiply by derivative of the second guy. So you have a 3 in front, keep the same quantity x minus 20, subtract 1 from the power, so it's 2, multiply by derivative inside, it's going to be 1 anyway, so that's that, right? Then derivative of 4 is 0, so I'm not going to write anything down, right? Then the next step would be I'm going to factor out the common factor. So you see that there's, let's see, quantity x minus 20 squared, right? There are actually 3 of them here, so I'm going to circle this so that I know that there's another x minus 20. So factor quantity x minus 20 squared, right? Then we just collect the leftover terms. So from the first term you still have x minus 20, so x minus 20, right? So that would take care of this guy right here, right? Then you have now you have a 3 distribute to x, so you have 3x, so plus 3x, right? And then you can distribute 3 to negative 4, so that will be negative 12 there, right? So you have, right, so this guy is actually, I'm gonna just rewrite. So this combined together is going to be 4x, combining these two guys, and a minus, right, 20 and 12, so minus 32, right? So 4 is in common, so I'll pull out 4. Then you have quantity x minus 20 squared. Right, if you pull out 4 from 4x, you have x, and pull out 4 from 32, 8, negative 8. You have that, right? So we're gonna set that equal to 0 to find the critical number. So you can see that the critical numbers are x equals, right, from here 8, and from here x equals 20. Alright, then we just need to find, evaluate the function at the critical values. So these are critical values and also endpoints. Right, so let's look at that. So we need to look at the 4 different places. Right, it's going to be f of 6, f of 8, and f of 20, f of 22. Alright, so what's f of 6? So we plug in 6 here. 6 minus 4 is 2. Right, 2 times right? 6 minus 20, so it's going to be negative 14 cubed plus 4. Right, so this is going to be equal to, I'm going to cheat. Alright, so it's going to be 2 times, right, negative 14 raised to the third power and plus 4. Right, so get that value. So that came out to be negative 5,484. All right, and plug in 8. So if you plug in 8 here, so 8 minus 4 is 4, right, times, right, 8 minus 20 is negative 12, and cube plus 4. Right, so that would be 4 times, right, negative 12 raised to the third power plus 4. Right, this came out to be negative 6,908 and 20. So if you plug in 20, you can see that it's 20 minus 20 is 0, so it's going to be I'm gonna write it anyway, so it's gonna be let's see, 20 minus 4 is 16, and you're gonna get that 0 cubed plus 4, which is going to be 4. Right, and 22. So if you plug in 22, so that's going to be 22 minus 4 would be 18, right, times, and 22 minus 20 is 2 cubed plus 4. Right, so that's so 18 times 2 cubed is 8, so 8 plus 4. Right, so this is 148. Right, so you can see that the absolute minimum is this guy, so right here is the smallest, so this is the absolute minimum, which is this guy, and the largest value is 148, so this is the absolute maximum because this is the largest guy. Alright, so let's type it in. Alright, so absolute maximum, it occurs at the x equals 22, then value was 148. Alright, so let's check the answer. Alright, we got that. And absolute minimum occurs at when x equals 8. Then it came out to be a rather big number, negative 6,908. Oops, there's one extra 0. And check the answer. All right, we got that. All right, that's it. I hope that this was clear.